This episode is brought to you by the Music for Scientists album, now available on all streaming services. Over the years, humans have made plenty of time capsules to preserve snapshots of the past. But incredibly enough, long before we were around, the universe was already creating time capsules of its own. Today, we know of a handful of cosmic objects that preserve clues about the distant past, from little balls of carbon to huge groups of stars. And by exploring them, we can uncover some amazing details about the universe around us. First, oddly enough, cosmic time capsules don't have to be very big. In fact, some of them are microscopic, like Buckminster fullerene molecules, better known as Buckyballs. These molecules are just a billionth of a meter wide, and they're made of 60 carbon atoms in the shape of a soccer ball. But even though they're made purely of carbon, when they form, sometimes they trap smaller particles and carry them along. And that's one thing that makes Buckyballs so interesting, because those trapped particles can say something about the environment where the molecules formed. For example, in a 1996 study, researchers were looking at buckyballs that they found on meteorites. They wanted to figure out if the buckyballs had come from space or if they formed on impact. So they heated the molecules to crack them open and release the gases trapped inside. And they found helium, but not like the kind on Earth. See, this gas comes in two forms, helium-3 and helium-4, which have different numbers of neutrons. Helium-4 is much more common overall, but on Earth, the ratio is especially high. That's because radioactive elements in Earth's crust and mantle are pumping this stuff out. Meanwhile, in space, the ratio is much smaller. So by analyzing the composition of the gas inside these buckyballs, scientists could tell that these little carbon cages were extraterrestrial. But also, the ratio didn't quite match the environment in our solar system. It was a little too high. So researchers suspected that these buckyballs were old and that they might even have formed around a different star billions of years ago. If they're right, that means these molecules potentially preserved a snapshot of an environment around another star before the solar system even formed. Not all cosmic time capsules are so tiny and obscure, though. Like, some of the most common ones we rely on to learn about the early solar system are asteroids. Because they're so much smaller than planets, asteroids don't evolve the way that planets do as they form. So they can tell us what the solar system was like billions of years ago. The problem is, anything that orbits in the inner solar system is still subject to the sun's heat and radiation, so it's not perfectly preserved. But there is one type of space debris that's almost pristine: rocky comets. Generally, comets are icy, dusty leftovers from the formation of planets that got kicked into the outskirts of the solar system. Normally, when they swoop close to the sun, they heat up and some of the ice vaporizes, leaving behind a long, shining tail. But astronomers have also discovered a couple of strange comets with barely any tail, ones that aren't really vaporizing. They call them Manx comets, like the tailless Manx cat. And astronomers expect them to be especially good time capsules of the early solar system. They're likely made of the same stuff that formed Earth, but since they stayed so far from the sun, they haven't gotten cooked like most asteroids. So the amount of water and other chemicals they release as they heat up could represent the composition of the disk of material Earth formed from. Since this discovery is relatively new, no one has scheduled a mission to one of these comets just yet. But we are getting better at sampling asteroids and comets all the time, so there's no reason we couldn't do this in the future to learn more. Finally, looking at the early solar system is one thing, but looking into the early universe is a whole other story. To do it, you often have to look at objects really far away. That's because light takes time to travel, so light from the most distant objects left when those objects were still very young. Meanwhile, most closer objects formed when the universe was much more evolved, so they can't tell us much about the past. Except now and then, we can get a glimpse of an ancient universe right in our own neighborhood, thanks to globular clusters. These are groups of stars that first started forming less than 1 billion years after the Big Bang, as gravity pulled the first stars together. As the universe changed, many of these clusters got pulled into galaxies, but they themselves haven't changed much, because they're so dense that they stay tightly bound together as one unit. For example, the globular cluster NGC 1466 is basically right next door. in the galaxy known as the Large Magellanic Cloud. But scientists think it formed 13.1 billion years ago, shortly after the Big Bang. These ancient clusters can tell us a lot, but one thing we can use them for is estimating the universe's age. We do have other ways of measuring this, but it's important to check our work, especially when we're throwing around numbers like 13.8 billion years. The key to this technique is that since globular clusters formed so early, the oldest ones should be about as old as the universe itself. So in a 2020 study, astronomers set out to estimate the ages of different globular clusters, judging by the composition of the stars inside of them. And fortunately, the numbers check out. What's incredible about all these time capsules is that they contain snapshots of the universe at different points in time. And by cracking them open, we can start to piece together how it went from a bunch of hot gas swirling in total darkness to a universe full of light, structure, and even living things. If that kind of exploration and discovery is making you feel all the things, you might enjoy an album called Music for Scientists. It's a tribute to those who poured countless hours and energy into science-driven work, and it was inspired by the incredible, knowable wonders in the universe around us. It's a project by Patrick Olson that celebrates scientific contributions to society through experimentation and commitment to truth. If that sounds like something you'd enjoy, you can find a link to the music video For Your Love below, or stream the album on all major music services.